full equation that contains rational expressions. And the reason that this one tends to be simple is because they all have the same denominator, right? Okay. So if they all have the same denominator, basically we don't even have to worry about the denominator because they're all the same. So we really just need to focus on our numerators. So like I can just rewrite this as 1 plus x equals 3. And then how would I solve that? Subtract 1. So we would get x equals 2. And we would be done. And remember on Thursday we had to talk about restrictions. Like whatever would make a denominator 0, we would have to say x could not equal that. Well, we don't have to worry about that here because all of our denominators were 5 in the beginning, so it doesn't really matter. Okay? You are not going to be tested on these because that is way too simple for an Algebra 2 class. Okay, you're going to be looking at solving equations like this one below. Okay, so solving is like adding and subtracting, except after you get the same denominator, you basically get to just ignore it and solve using the new numerators. Now, the way that describes it is not necessarily the way I do it. I like to stick with what we were doing on Thursday because then it just makes more sense. Like on Thursday, we would go through and we'd find a common denominator, right? Remember how I would have you guys determine your common denominator and we'd write it out to the side? Yeah. Okay, so the way we find our common denominator is anything 2 or more of the fractions have in common, we use once. So what's something all of your denominators have in common? The k. This has a k and this has a k. So we know for sure we're going to use k. And then anything that they don't have in common, we also have to use. So what else? The 2. And remember, we just multiply them together. Okay, so our common denominator would be a 2k. Are you with me so far?
I'm with you.
All right. So now, if this is our common denominator, I do a process called clearing the denominators because I want all this stuff on the bottom to disappear. It'll make our lives a lot easier if we can just ignore them. So, in order to clear the denominator, we're going to take this common denominator and we are going to multiply every fraction by that common denominator. So on Thursday, you only had to worry about 2 fractions. Here, we're going to be focusing on 3. Okay? Now look at the first fraction. When we multiply by 2k, is there something up top that can cancel out the bottom? What up here could cancel out that? Okay, so this k cancels this k, and we're just left with 3 times 2, which is 6. All right, then out of this, what up top cancels out the bottom? The 2 cancels this 2. So then aren't we just left with a 1k up top? And there's a minus sign in front of it, so make sure it's minus 1k equals, and then over here what cancels top and bottom? The k. So 12 times 2? 24. 12 times 2 is 24. Huh? It's okay. All right, now look at that. Look at how simple this has become in comparison to how it started. Okay, so clearing the denominator is finding the common denominator and then multiplying every numerator by that denominator. And what should happen is something up top should always cancel out the bottom. So then that way we're just left with, I mean, this is going to be a 2-step equation, but potentially you could be left with like a multi-step equation. You could be left with a quadratic that we'll have to factor. There's all kinds of things that can happen, but it'll be a lot easier to solve once those fractions no longer are fractions. Okay, so what's my first step in solving this? Subtract 6 from both sides. So when you bring down the 1k, make sure you bring that negative sign with it. And then what's 24 minus 6? 18. And then divide by negative 1.
I just forgot, now I know.
So k equals negative 18. Okay, now, before we say that we're done with this problem, we do need to talk about restrictions, because in the beginning, we did have, in the original problem, we had a k on the bottom. What's never allowed to be on the bottom of a fraction? What number? Okay, so right off the bat, I should have written down that k is not allowed to be 0. That would be a restriction, but our final answer was negative 18. And if I plug in a negative 18 up here on the bottom, you're allowed to have a negative number on the bottom, so this negative 18 is fine. The only number that we would not be able to have as our answer is k equals 0. So you have to tell me what kind of restrictions we have, and we're going to solve. Okay? How's that? Is that okay? All right, when you're ready, turn the page. Things are about to get a lot trickier. All right, so now we've got 2 more examples of this type of problem. Now look at our, again, even on Thursday, before we did anything, I told you guys, don't look at the tops. I told you to focus on just your denominators, and if any of the denominators were quadratics, so like this one, I told you you had to factor it, right? Because we have to factor this to see if it has anything in common with these. So we need to start by factoring this to see what that denominator actually really is. So that's an asterisk problem, right? We have a positive 8 and a negative 6. What 2 numbers would multiply to give me positive 8 and add to give me negative 6? What kind? Negative 2 and negative 4. Yep. Okay. So, once you guys have factored that, you don't want to look at this form anymore. You want to look at it in its factored form. Okay, because now we're going to use factored form here, and we're going to compare it to these. And remember, anything that 2 fractions have in common, we're going to use once, and anything that they don't have in common, we'll use once. Okay? So tell me something that at least 2 of our fractions have in common. The x minus 2. And what else? The x minus 4. Now I promise you, and I said this on Thursday, I am never going to give you a problem where the common denominator would have more than 2 sets of parentheses, okay? So knowing that, look at the original problem. This was x minus 4 and this was x minus 2. If this one over here had factored to anything else besides these 2, wouldn't I have had a 3rd set of parentheses? I'm not going to do that to you. So it kind of helps you with the factoring, because I know that these 2 had to have been how this one factored, because I would have never given you something that would have had a 3rd part, like a 3rd set of parentheses for your common denominator. Okay? So now, this is the tricky part, because what I need to do is, once you identify this, we are supposed to multiply every single numerator by the common denominator. It's kind of hard to squeeze it in, So what I'm going to do is I'm going to rewrite my problem with more space. Like I'm going to space it out so you guys can actually see. I think that was a little excessive. Like here was the original first fraction, the 1 over the x minus 4. But then I'm going to put an x minus 2 and an x minus 4 next to it. I'm going to just squeeze this plus sign in right here. And then the second fraction started out as this, like x over x minus 2. But we need to multiply it by the common denominator. So I'm going to squeeze both of those in up top. And then equals, my last fraction had 2 over x minus 2 times x minus 4. But then don't I have to multiply the top by x minus 2 and x minus 4? Okay. I could have, if you guys actually wrote small enough, you could have done it right here. Like you could have squeezed them both in. But sometimes that is kind of hard to do, especially on a worksheet where the print tends to be a little bit smaller. Watch what happens. This is the good part. If there was already an x minus 4 here, and you multiplied it by both of these, won't my x minus 4s cancel each other out? Okay, so let's distribute here and figure out what that would be. What's 1 times x? 1x. And what's 1 times negative 2? Negative 2. So now my first fraction has simply just become 1x minus 2. Now the middle fraction. It already had an x minus 2 on the bottom to start with. So the x minus 2 on the bottom will cancel with the x minus 2 that we just multiplied it by. But that leaves an x times an x minus 4, right? Okay, and it's a positive, so that's good. What's x times x? X squared. And what's x times negative 4? Negative 4x. Equals, now the right side's even better because look, this one already had these two on bottom, and we just multiplied the top by the same 2 sets of parentheses, so won't everything cancel except for the 2? Yeah. So that big mess of a problem just now became this equation. All right, do you guys see this? See how it says x squared here? I always put the x squared first because this is a quadratic. Now we can combine these two, can't we? The 1x minus 4x, what does that make? Minus 3x. And then I'd still have a minus 2 equals 2. And with all quadratics, everything has to come to one side, right? This has to be set equal to 0 in order for us to factor it. So how do I move this 2 over? We're going to just subtract 2. Make sure you line it up with the other negative 2, because that's the one it's going to pair with. So we have x squared minus 3x minus what? 4 equals 0. And now it's time, in order to solve for x, we are going to have to factor that quadratic. That is 3 terms, so we can just do an asterisk problem. We've got a negative 4 up top and a negative 3 on the bottom. What 2 numbers would multiply to give you negative 4 but add to give you negative 3? Negative 4 and 1. Okay, so my 2 sets of parentheses are x minus 4 times x plus 1 equals 0. So then from there, can you guys give me the 2 answers? X equals and x equals? Positive 4 and negative 1. Okay? So now we have two possible answers. And what we need to do is we need to go back up to the original problem and we need to figure out what our restrictions would have been. Okay, so if I go back up to the top, there was an x minus 4 on the bottom. So what could this x not be? Positive 4. That's a restriction. And what could this x not be to cancel out the minus 2? Positive 2. There are the restrictions. Okay? If those are the restrictions, that means if you get either of those answers at the end of your problem, it's not an answer. It's not a possible solution. Did we get either of those when we just solved? We got the positive 4. So positive 4 is not a solution. So even though you guys solved it and you got two possible answers, sometimes both of them will be fine. Like if this had been a positive 5 and a negative 1, it would have been fine. But since there was a positive 4 and that was one of our restrictions, you just cross it out. And negative 1 is the only possible solution to this problem. Is that okay? All right, then one more. So if you guys look at all of your denominators again, tell me which one needs to be factored. Yeah, this middle one, I need to figure out what the two sets of parentheses are. So we're going to go and do an asterisk for that. We've got a 5 and a 6. What do you guys think? 1 and 5. Okay, so we have b plus 1 and b plus 5. All right, before I go any further, let's do the restrictions now instead of waiting to the end. Because I end up crossing a whole bunch of that stuff out, and then it just gets a little bit harder. So what number would I plug in right here to the b plus 1? That would make that 0. Negative 1. And then how about the b plus 5? Negative 5. Okay, so right here, these are the restrictions. Those are the two numbers you want to look out for. So when we get our final answers on this problem, if either one of these pop up, we're going to just cross it out. If neither one pops up, we're good. Okay. So now let's establish our common denominator. Let's write it over here so we've got some space. Okay. All three fractions actually have something in common, right? All three of them have a b plus 1. So we know we're going to use the b plus 1. But then what's the piece they don't have in common? B plus 5. Yeah, so we have to use that as well. So those are the two sets of parentheses that make up your common denominator. Now I'm going to show you guys a little shortcut. Because remember how up here, squeezing in both sets up top was a little difficult, like you don't really have the space for it? Well, if I knew that I was going to put both of these up here and I already had the x minus 4, couldn't I have just crossed out the x minus 4 and put the x minus 2 next to it? I could have. So let's try it that way so you guys don't have to like use so much room here. If I were to write, so look up here, if I were to write both of these next to this numerator, which one of those would cancel out the bottom? So the b plus 1 would be gone, leaving behind the what? B plus 5. Okay? All right, now look. If I put both of these up top next to the 2, but I already have both of them on the bottom, what happens? These two would cancel out those two, and all I would have up top is the 2. There'd be nothing left, like, to put with it. How about this last fraction? This b plus 1 would cancel this b plus 1, leaving behind the b plus 5 up top. So you can use that shortcut if that shortcut makes sense to you. If not, you're going to have to do what I did up here and have to write both of them up top, see what cancels, and it'll take you a little bit longer. This is a little bit easier if you just use that shortcut, but you have to think ahead. You have to figure out which one of these would cancel and which one would be left behind. The left behind one is just going to be whichever one wasn't already on the bottom. Hopefully that just made sense to you guys. Okay, so now when we work out the top up here, this was easy because this was just one term times two terms, so we could just distribute. So was this one. This is not one term times two terms. This is 2 by 2. And for every problem that we have a 2 by 2, it's what? We have to make the box, right? We have to draw out a rectangle or a square and do that multiplication. So the top of that one, you can't just do b times b and 5 times 5. You're missing the middle term if you do that. So that right there is a box problem. So then here we go again. We've got to do some extra work off to the side. We're multiplying b plus 5 times itself. And then let's talk about what we would get. B squared. What would this corner be? 5b. It's a positive 5b. And then the bottom row, 5 times b, is also 5b. And then what's 5 times 5? 25. Okay? So now remember, this is the first numerator, so this is what we're going to write first. I would have b squared plus how many b's? If you put these together right here. 10, yep, plus 10b, and then you'd have the plus 25. Then you're going to bring down that equal sign, because that was next. We didn't have to multiply the 2 by anything, so we're just going to put a 2 plus, now this last fraction, this is okay. This is just one term times two terms. So that one we can just distribute. 1 times b, 1b, yep, and 1 times 5, 5. So all this stuff over here, this was all side stuff that we had to do to make this problem happen, okay? All right, now look at what I see. I see a b squared, which means all this stuff over here needs to come over, right? Because I'm going to have to factor. So, I don't know how you guys want to do this. If you were to put these two together, wouldn't that be a total of 7? And then if we brought it over, wouldn't we just be subtracting 7? Okay, so that's going to cancel out those. And then wouldn't we also have to subtract a 1b? Because that'll cancel out those. And that would give us a 0 on the right side. So we're going to bring down b squared. What's 10b minus 1b? 9b. And then what's 25 minus 7? 18. So now don't we have to do another asterisk problem? Isn't this problem fun? We're doing all kinds of stuff here that you guys have done a ton of, all within the same problem. It's good stuff right here. Two numbers that multiply to give us 18 and add to give us 9. 3 and 6. So we have b plus 3, b plus 6. Okay. What would this one give me as my final answer? B equals -3, bless you. How about this other one? -6. Okay, so now that we have two possible answers, do either of those match any of the restrictions? No. So since these are not included in the restrictions, that means both of them are correct. Like both are possible solutions to that problem. Okay, so I know that's a lot of work. But then we're also going to roll over to the next page and we're going to continue doing some of these equations, but the ones that we're about to do are way easier. They're word problems, so a lot of times people freak out because word problems in general cause people anxiety. But these word problems are really not all that complicated. It's going to be, we call them like word problems involving work being done by two people. So potentially, if you guys just think about this, if I gave two people the same job and they worked independently, more than likely they're not going to work at the same speed. Somebody may be a little faster than the other. But then what would happen if you put those two people together? Wouldn't you think that the two of them could get the job done faster than if they worked separately? Yeah, that would make sense. So on some of the word problems, I'm going to give you two individual times, and we're going to find how long it would take if they worked together, which should be shorter. Or I'm going to give you how long it takes them together, and then like one person's individual time, and you'll figure out the other person's individual time, which should be longer than the together time. Okay? So if you guys turn the page, it says, for the working word problems, we're going to take the work done by person number 1, we're going to add it together to the work done by person number 2, and we're going to set it equal to 1 every single time because this person does this portion of the job and this person does this portion, but together they would make one whole job. Okay? All right. Down here at the bottom. Here's your first example. If James can fill an order in 10 minutes working alone, and Matt can also fill the same order in 10 minutes working alone. Okay, so again, that's not very likely. Most people are not going to work at the same speed, but in this first example, they are going to tell you it's taking them both the same amount of time, and they want to know how long will it take if they work together. So this is how it is set up every single time. Look, set it up like this. We're going to have James's portion of the job plus Matt's portion of the job, and together it'll be one whole job. Okay, so now if you, like we said before, if two people work together, you would expect that to be the smaller number, right? Right? Because it's going to take them less time if they work together. So since I don't know how long it takes them together, we're going to just use a variable up here, and I always just use the letter T. So that's like the total time they work together. And then on the bottom, you put their individual time. So like for James, he was 10 minutes, and for Matt, he was also 10 minutes. That's the equation we're going to solve. So my first question to you is this. What's the common denominator for this problem? It's 10. And once you establish that common denominator, aren't you just supposed to multiply everything by that? Okay, so watch. You might want to look up at the board when I do this. I'm using a different color so you can just see. I've established my common denominator, and I've now multiplied everything up top and this one by that common denominator. Look what happens here. This 10 cancels this 10, and we're just left with 1t, right? Plus the middle fraction. This 10 cancels this 10, and we're left with 1t. Now after the equal sign, nothing cancels. It's just 1 times 10, which is 10. Much easier equation to solve. What's 1t plus 1t? No, that's if you're multiplying them. 1 plus 1 is 2t equals 10. And then what would I do to solve that? Divide by 2. So if they worked together, it would take them 5 minutes. Now most people would have said, well, I could have just figured that out. If they each took 10 minutes apart, then we could just cut it in half and it would be 5 minutes. Well, you know the reason that that works on this problem? It's because the two of them took the same amount, like they were working the same speed. Most of the time, that is not going to be the case. So then if you guys keep reading, it said, what if James took 20 minutes by himself? So they're not changing the amount of time it takes for Matt, but instead of James taking only 10 minutes, now we're going to say, okay, well, James is going to take 20 minutes by himself. Matt is still going to go a little bit faster. He's going to work the 10 minutes, and then we're going to set it equal to 1 total job. So this second part of the problem, I am working out over here. This is James. This is Matt. James, Matt. Okay? All right, so let's talk about a common denominator for these guys. No. A common denominator for a 20 and a 10. Well, you can just go ahead and multiply the two of them together, can't you? What's 20 times 10? 200? Sure, let's use 200. The fastest way to get a common denominator, if you don't, like, I could sit here and I could count by 20s and I could find the first number that 10 goes into. Like, honestly, the smallest one I could have turned them both into was a 20. If you can recognize that, we could be using 20. But if you don't, like if it's a number like 15 and 35, and you don't want to sit here and count by 35s until you find a number that the 15 goes into, fastest way to get a common denominator is just multiply the two of them together. Okay? So the 200 is what we're going to multiply the top by. So I'm going to put times 200 here, times 200 here, and then times 200 next to the 1. And watch what happens. I hope you're watching. 200 divided by 20 would be what? The 10? So it leaves a 10 behind with the t. So that's 10t. What's 200 divided by 10? So it leaves behind a 20 with the t. So far on the left side I have 10t plus 20t. And on the right side, what's 1 times 200? 200. Okay, these are on the same side, so go ahead and add those together. What's 10 plus 20? 30t equals 200, and then we would divide by 30. Now look, it's not going to be a whole number. That's okay, because this is just minutes. So just carry it out like 1 or 2 digits. Okay, so I'm going to actually just put 6.6 repeating, since that 6 does repeat. So it would take them 6.6 repeating minutes to complete the job if they were working at the different speeds. How do you guys feel about that one? Okay, now remember, this example that we just did, both of these, they gave you how much the individual time was. Okay? So if I get, like in a minute, I'm going to switch it, and instead of giving you individual times, I'm going to give you like one individual time and their together time. Okay? But I think we're going to do one more like this, and then I'll switch it up. So do me a favor, while we're waiting, go ahead and read the next problem. So read that problem up there about, what is this, Nia and Max. And I want to see, I don't expect you guys to work out the whole problem on your own. I just want to see if you can get it set up correctly. This is just like the kind we just did. So you will put somebody's individual time here, somebody's individual time here, and then since we're looking for how long it takes together, what goes up top? What goes up top? Or T, right? Whatever letter you want to use. Okay. Okay, what numbers go on the bottom? 45 and 30. Okay, so once you have it set up, I mean, if you guys wanted to right now, you could count by 45s, you could count by 30s, and you could find the first number they both go into. Or, just to save on some time, couldn't we just multiply the two of them together? It's a big number, but that's okay. We get to use calculators. What's the number? 1,350. No big deal. So now take that common denominator, go ahead and throw that number up here next to each numerator and next to the 1. And then if you take, so you guys look, in this first fraction, if you take 1350 divided by 45, we get the 30, so it leaves behind a 30t. Plus, and then if you take 1350 divided by 30, it leaves behind 45t equals, and then on the right side, 1 times 1350 is 1350. So now we can just add and then divide, right? Add these two, giving us a total of how much? 75t. And then we'll do our division. And you guys let me know what you get. 18, and that's in minutes, correct? Okay. All right, so that is the last example of where you're given their alone time, okay? So then the next couple problems we're going to do, I'm going to switch it up. Now, the setup is still the same. Like, you're still going to have a fraction plus a fraction equals 1, okay? So I am going to go ahead and down here at the bottom, this is just every time I have one of these problems, I just go ahead and do this just to get myself ready. And then we'll read through it and we'll start filling in like the different pieces. Okay, so you guys tell me, what do you think? If working together, Ashlyn and Morgan can clean the house in 2.4 hours, that was when they were together. Where does the together time normally go? At the top, right? And they're both going to be the same. So for each person, the top number is going to be 2.4. Just like before, we made them both t's. Well, now we know that it's 2.4. Then it goes on to say, Ashlyn takes 4 hours by herself. Does it matter which fraction I put the 4 under? No, I mean, it doesn't really matter. I'm going to put it on the first one. Then they want to know how long is it going to take Morgan by herself. Okay, so whatever letter you want to use, if you want to use T, I always use T for time, but you could use M for Morgan just to keep it straight. It doesn't really matter. I'm going to use a T. All right, so let's talk about our common denominator this time. Common denominator this time is going to be way easier because you have a number and a letter. So it's going to be 4t. I like these because when it's just one number, one letter, you just attach them. And the 4t is what we're going to multiply everything by. So times 4t there, times 4t here, and times 4t at the end. And everything's going to cancel out on the bottom. Okay, so what up top cancels with this? This 4 cancels this 4. So we're just left with 2.4t. And then we'd have a plus sign. And then what cancels in the middle? This t cancels this t. So you guys will have to do 2.4 times 4. 9.6 equals, and then what's 1 times 4t? 4t. Okay, so notice how now the t's are on opposite sides. So on these problems up here, the t's were on the same side, so we added them. If they're on opposite sides, we're not adding them. Don't I have to move this one over here by subtracting it? Yeah, so we're going to subtract 2.4t. So we have 9.6 equals 1.6t. And divide by what? 1.6. So then what's 9.6 divided by 1.6? 6 hours. So that's Morgan. It would take Morgan 6 hours if she was working by herself. And you know, just one thing to keep in mind is this problem up here, we were looking for how long it would take them together. Well, individually it was 45 and 30, so shouldn't the final answer have been smaller? And it was. But down here, it was 2.4 together, so Morgan should definitely be longer than 2.4, and it is. So that's just one thing to kind of ask yourself at the end, like, does this amount of time make sense for whichever type of problem I'm doing? Do you guys feel okay with those? No, that's fine. I just wanted to make sure you guys are okay with how that one was worked out. Okay, those of you that are caught up, you can go ahead and turn it over and see about maybe getting this last one set up. It's the same type that we just did. So they're going to tell you how long it takes So somebody's draining a pool and there's there's like one hose here and one hose here. So you're trying to figure out, like, together, both of them could drain the pool in, what does it say, like 2.25 hours? But then one of them would take 9 hours by itself, and we're trying to find the other one. See if you can at least get it set up.
All right.
Yeah. So we said 2.25 up top. And then on the bottom, one of them would be 9 and the other one, whatever letter you want to use. Yeah, I'm just going to stick to T's the whole time. All right, so what is the common denominator? 9t. So then you want to make sure that you show that we're multiplying every fraction, so all the numerators or just this whole number over here, by 9t. And in the first fraction, the 9 up top would cancel the 9 on the bottom, leaving behind 2.25t. And in the middle, the t's would cancel. So you've got to do 2.25 times 9. 20.25. And then on the right hand side, 1 times 9t is 9t. And then we would just move our t's, move the 2.25t over, subtract it. So we have t's on one side, constants on the other. So we've got 20.25 equals 6.75 t, and then finish with your division. And then that'll be, once we finish this one, that's the end of our notes, and I'll give you guys your practice page. So you guys get 3 hours. Okay, so I just wrote under there, I put t equals 3 hours, and I just said it was the second hose, because that would be how long it would take that one by itself. And that's the end of your notes.